Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over how to calculate the KSP from molar solubility. So first thing you're given is you're given the salt and you're given its molar solubility. And so now you have to figure out how to get KSP. So the first thing you need to do is write out your balanced equation of the salt dissolving in water. So for this one it would be silver sulfate solid going into silver ions. Okay, so you'd have two silver ions here, aqueous plus sulfate ion, aqueous. Okay, so then you're going to write the next thing you're going to do is you're going to write your ice table, create your ice table, and we're going to look at the change in these two during the dissolving. So because this is solid, we're really not going to pay attention to this in our KSP expression. So we need our equilibrium expressions for how much dissolved so that we can put that in and create our KSP expression. So in the beginning, initially, it's all going to be solid, and it's going to be zero amount of the ions in solution at the very beginning. But then it's going to dissolve, and there's going to be a change. You're going to lose some of this. Because it's a 1 to 2 to 1 relationship, then whatever you lose here, it'll be twice as much of a gain here. So it's going to be plus 2s here, and it's going to be equal gain here. So this is going to be a plus s. And so when you add these together, we're ignoring the solids. We're only looking at the ions. When you add these together, you get plus 2s, and you get plus s. Okay, so now that we have our equilibrium expressions in terms of molar solubility, we can put this into our equation. So our KSP, if we write that down, so KSP is going to be equal to the concentrations of these two. So it's going to be the concentration of silver plus raised to the second power because of the 2 coefficient multiplied by the coefficient of or concentration of SO4 2 minus. And so now all we need to do is plug in our equilibrium expressions in terms of molar solubility. So this is going to be 2s squared. So this is going to be 2s squared times s. And so then that's going to be 4s cubed. And that's equal to KSP. Okay, so now let me go ahead and erase this so we can make some room. So now I have the KSP, so we have KSP is equal to 4 times the molar solubility squared. Well, we're given the molar solubility here, so we just plug that in. So it's going to be 4 times 1.4 times 10 to the negative 2 molar, and then that's cubed. So now to find the KSP, all we need to do is do the calculation. So let's do that calculation. We do the calculation and we get 1.1 times 10 to the negative 5. So then KSP is equal to 1.1 times 10 to the negative 5. So that's the KSP of silver sulfate. Okay, what's the next one? So the next one is silver bromide. Here's the molar solubility of silver bromide. We're going to do the same thing we did up here. So we're going to have silver bromide solid. That's going to break up into ions. Again, silver plus aqueous plus bromide ion aqueous. And so we're going to do our ice table again. So again, we're only looking at the ions since those are the ones that are changing. Solid is we're going to ignore. So we're going to begin at first. No AgBr has dissolved. So we start with 0. After some time, some of this is going to dissolve. So we'll get a certain amount. Since it's 1 to 1 to 1, this is going to be a plus S. Whatever the molar solubility is, this is going to be plus S. So we're going to be using that. And then we add these together, the equilibrium amounts is going to be plus S and plus S. So then we can do our KSP expression. Now that we have our equilibrium amounts that have been dissolved, KSP then is going to be equal to the concentration of these two. So it's going to be the concentration of Ag plus times concentration of Br minus. And now we can put in our S values. So this is going to be equal to S times S, which is equal to S squared. So KSP is going to be equal to S squared. Here's our S, here's our molar solubility, so we plug that in. So 7.3 times 10 to the negative 7 squared. And then that becomes, that's going to be 5.3 times 10 negative 13. So KSP is equal to 5.3 times 10 to the negative 13 for silver bromide. So that is how you can figure out the KSP from the molar solubility of your salt. I hope this is helpful. I hope you enjoyed this video. Please let me know in the comments below. If you like my videos, please like, share, subscribe, hit the notification bell. Thanks for joining me, and I will see you next time.